So, hello and welcome to the third edition of the VDMA event RoboLunch, organized by the VDMA Robotics and Automation Association. My name is Juliane Kluge. I am the project manager of the VDMA Working Group Industrial Drone Solutions. So please feel free to enjoy your lunch as always, and we will garnish it with three fascinating stories. The motto for today is ready for takeoff, drones and automation. Each presentation will be 9 minutes long with 4 minutes of Q&A. Please ask your questions in the meeting chat. Your cameras and microphones are switched off by default settings. Please note that the VDMA compliance rules apply and that we record this event. So our program today features inputs from Halitex, SpleenLab, and Denkweit. The startups share their drone application examples with us. Dominik Feist will introduce Halicopter, a semi-autonomous drone system. Dominik Lausch will give examples of quality control of individual objects by drone technologies. And Maximilian Hausmann will talk about safe automated inspection flights. So let's start and go straight to our first speaker. Dominik Feist is a software engineer at from Halitex GmbH. You know about the time. So the stage is yours.
Yeah, thank you really much. I hope you are able to see the slides now. Really nice. Okay. Yeah, thank you really much for your kind introduction. And I would also like to welcome all listeners who are here today and wish you a pleasant lunch break. So my name is Dominik Feist. I'm a software engineer from Halitex at the Lake of Constance, and we are a small startup which was founded at the end of 2020 in the field of system and process automatization. Which we could already show by developing a full automated system for the production of FFP2 masks. However, today I would like to introduce you to our new project of our team, where we want to redefine the previous limits of drones. And according to our company name, we call this project the Halicopter. But before that, I would first like to ask a question: what is a copter? A copter is a drone and therefore an unmanned aerial vehicle, which is characterized by the fact that it can, if done right, autonomously perform tasks in the air or be controlled by a person from the ground. Most of you will be familiar with drones mainly in the form of multicopters, like you can see here. And and in the recent years, those have also been enjoyed by private users and hobby pilots. They usually consist of a main body, including the power supply and the control electronics of the system, as well as several arms to which the motors and rotors are attached. Centrally below the copter, a payload can be attached, which is a camera in most cases. So similar to a helicopter, there's a huge amount of theoretical applications, while a pilot is not necessarily required. And in the private and government security sectors, drone flights can therefore be used for supervised or automated reconnaissance of different areas and situations. And in addition, applications in the transportation, the agriculture, and for the camera control in the media industry are feasible. And now you should be asking yourself, but then why aren't drones already established in those fields for a long time yet? Well, that's a good question, and the answer is quite simple, because the main problem here is that those small model-derived drones are rarely built strong enough to be used under all possible environmental conditions. And in addition, the flight time of common systems is only between 15 to 30 minutes with a payload of a few hundred grams, and this is not suitable for the named tasks. If we have now a look at the Bundeswehr, we can see that several unmanned drones systems for mobile applications, as well as a copter, are already in use. In a direct comparison of these drones, the Mikado quadricopter is obviously inferior to the other drones in terms of the possible flight time and the operation height. But however, for a price several times lower than the other systems, you get a platform that is ready to use within just 5 minutes and almost completely free of maintenance. And to compare this to the other drone systems, I brought here official video footage from the Bundeswehr. And what you can see here is the assembly of the KZ-0 drone for the mission, which has to be done by a team of at least 4 men. And since the 170 kilogram drone is not able to take off on its own, it's shot out of a container with the help of a booster, which you can see here right now. And this booster is not enclosed in the system, and therefore it has to be collected and refilled after use. The Aladdin drone on the other side can be launched by a soldier in from the hand, while the Luna drone needs a launch ramp again. And for landing, parachutes in combination with airbags on the underside of the drone are used, as well as huge safety nets. So while landing, it often happens that parts of those drone systems break and have to be repaired afterwards, which is quite frightening since those systems cost between 200,000 and 3 million euros, depending on the model. So I hope that after these pictures, you all agree with me that there's still room for improvements. And the approach we are currently working on at Harley-Tex is to offer a complete system that allows a robust and reliable use of drones for reconnaissance. But how we want to achieve this? Well, with regard to the drone, we are moving away from the common toy image and drastically increase the performance of the copter, since a high flight time also brings new possible applications. And therefore, we have developed a battery system based on round cells, just like Tesla, which should enable the copter to fly up to 90 minutes with a 5 kilogram payload. And the batteries and electronics are integrated into the supporting structure of a carbon monocoque, which you can see on the right side here. And this monocoque also allows us to store the payload, such as a camera, inside of the monocoque in a safe position. And in the flight, the payload can automatically move under the copter, ensuring an absolute unobstructed field of view. And to enable autonomous operations of the drone, it must have comprehensive communication capabilities. And for this reason, it is equipped with 5G and GPS. As alternative communication technologies, directional radio antennas and satellite link are included. And in addition, a 360-degree LiDAR scan is used to detect objects and obstacles in the possible flight path. To enable reliable supply and easy support of the transport of the drones, we are currently working on a concept in which a roll-off container system will be integrated as a mobile base for the copter operation. And this has the advantage that roll containers are already in use by several emergency services such as the fire department and the police, and enable our own infrastructure, with which I mean communication possibilities and energy supply. The copter is placed on a platform within the container, which serves as a lift and a landing platform as well. Next to the copter, a 6-axis robot arm is installed, which enables the autonomous exchange of battery packs and different payloads. And therefore, the drone is thus ready to use again within a very short time after landing without the intervention of any human being. To control the drone, a control cabin is set up in which the controller is placed. And on the installed screens, the pilot gets live data of the drone displayed, which includes the GPS position of the flight data, the flight data recorded by the inertial measurement unit, and of course the live images of the camera. Now that you know the concept of the system, you are probably asking yourself how far the progress is already. So in order to verify that the copter can actually deliver the theoretical performance, we have already built a prototype of aluminium, which you can see on the right side here. And together with the batteries, which are shown below, the prototype exceeds the target weight of the carbon copter by 19 kilograms. So it's equal to 90 kilograms of payload. And during a secured test flight, a flight time of 47 minutes was achieved with that setup, which means that with a non-optimized prototype, we already outperformed most of our competitors in terms of flight time and payload. The next steps are now to manufacture a carbon prototype and see if the targeted 90-minute flight time can be achieved with a lower payload. And furthermore, the development of the container system has to be started. And for this, we also still look for partners and possible investors. So if you are interested in this project, please feel free to contact me or my colleague Jan Hartmann, who is the team leader of this project. And for all immediate questions, I'm still available now or later in the chat. Thank you very much.
Thank you, Dominic. Just in time. So now, yeah, please share your questions in the chat if you have questions for Dominic.
Also, it's in the chat, all right.
So
I'm also here for the whole lunch break, so you can also ask me why the other presenters talk.
no questions yet in the chat. Oh, here's the first one. Looks very interesting, but what is really unique in your product in one word?
I would say just usability, because with we try to get a higher possible payload and also a much longer flight time than the other systems, and this enables you to use it for more applications. Yeah, so usability. Yeah. And also, like I said, we aim to deliver a full system, so we don't want to give just a drone to the market and you can look what you want to do with it, because when we if we have customers like the police or the military or who else, the container system should be fully unique. So it's an ecosystem which is for its own, can be controlled from the mobile central alone or from other central of the police or whoever wants to use it.
Yeah. And second questions, are there alternatives you are thinking about to fuel the drone, not using batteries, but fuel cells, for example?
Well, we thought about using fuel. I don't quite remember why we decided to use batteries actually, but like I said, we were able to exceed just with the prototype the flight time of other systems. And it's actually a question for my colleague Jan Hartmann, who is the team leader, why we don't want to use other fuel.
Yeah. And one question I asked myself in preparation for this, looking at your website, I can't see any hints on your drone project, but production of masks. Why?
Well, that's because the startup was just built for the FFP2 mask production, and the production is finished, or the machine is finished already, so we are currently just producing masks. And yeah, we are still some engineers who wants to build something new, and we were already interested in drones when we were in school. So this was a project which was in our mind always, and now we want to start it and give it a try. So it's just a conceptual part now, and you will probably find something on the website when you have partners and start it officially. Yeah.
I think last question, what kind of other applications do you have in mind?
Then those I already showed. I think those are the biggest actually. So when I go back to the slide here, yeah, I think for transport wise, you can transport goods if your drone is able to do that. If you have a high payload option and long flight times, and maybe far in the future, you could also transport persons if it's safe enough. And yeah, of course, it's again a question of payload. And in the agriculture, I have also some points written down below. It's you can integrate AI to analyze the video footage you get from the drone and analyze, for example, the health state of your plants. Or there are also some drone applications which try to put seeds into the ground. Yeah, or care about your plants in any way.
Okay, so time's up
Mhm.
for you. I think for further questions, you can contact Dominic afterwards.
Yeah, sure.
So big applause for you again.
Thank you very much.
Thank you very much. And now switch to the next Dominic. Dominic is CEO of the company Denkweit. And yeah, you have partnered with Flynex to address some challenges, and we look forward to learn from your experiences.
Yeah, thank you very much. Also, thank you very much for having the chance to present here. So as Fraunhofer startup, our motivation was to perfectionize vision AI technology for the industry and make it very easy, accessible. And we developed the technology quite a long time, but we are out in the market since 1 year, and we have succeeded, or we had got 30 partners in different countries. So that's our current stage. And what I want to show to you here is a solution which is a combination of two different solutions. So our Vision AI Hub and the Flynex platform. And the aim was to bring the best of two worlds together. So before I present to you the solution, I want to say something shortly about the Vision AI Hub. So the most partners in where we are working out of the industrial market. So we deal actually quite a lot with pick and place and also with analyzing of surfaces. And here on the left side, you see also our strengths in the upper corner. We need only very less examples to generate quite stable AI, so vision AI technologies. We are working also in we call this real life imaging. We work there with people who go through streets and look for SDVO objects. And our partner in the drone business is the company Flynex. So what's the Vision AI Hub? Quite quickly, you have here an access to all different AI technologies, from image classification to all the other stuff, pixel accurate object detection. And what you have to do, nothing which deals with AI technology. You press simply play, and we deal the rest in the background. And our strength here is that we need very less images, because without going too much into detail, we solve this optimization of the networks a bit differently. So we also optimize the network architecture, so the mathematics which is used for the case, for every case individual. And so the process is that you teach an AI in the Vision AI. then you can download the result and integrate it usually with a DLL, and that generates result. In this case, the AI, of course, is integrated into the Flynex platform, where you get, let's say, access to a whole solution. That brings me to the solution. So what was mainly honor to honor belongs, the work of Flynex, is that also with this combined solution, we have digitalized everything from the task to the report in the drone business. So our customers, so what you see here is the process itself, and I will go through every step and quickly show to you what you do and how you come to the result, which is the most important part. So our partners usually have assets or objects which they want to control or to fly, like bridges or like plants who have to check, let's say, on a monthly base or even more. So you can set up your objects here. Then you have to do a mission planning, which can be also done there. So you plan the flights, can export this, and also the platform tells you if you cross an area which you are not allowed to fly, and also optimizes the flight area. Then, of course, you have to fly. We have seen a very interesting technology before. There are a bunch of drones which you can actually nowadays access, and you fly and take the pictures or video. And then you upload this either by also an all-in-one Flynex solution or by hand to the platform, and that's now where we come into play. So the first thing what we do is we care about that all the images which you take or videos are GDPR conform, which means you have to get rid of the faces in case you want to share also the results. So it means also getting rid of also number plates of the vehicles, which is done in the background or by an action which you take in the platform. So afterwards, so you have uploaded the images, then you have to evaluate the images. And there you have now two different ways. So the first way is you can, of course, use an all-in-one solution from Flynex. They use our technology to set up what you want to see. But on the other side, which is to our point of view, and that's why we partnered up, this is a big strength. You can also do it on your own. I will tell you one example why it is necessary. We had one case where we had to analyze a bridge. And in this bridge, there was brown parts, and the question was, is the bridge okay or not? And it was super, super difficult, or actually impossible for us to decide if this is moss or if this is really rust from the underlying metal rods. So, and an expert, of course, he looks at the image and say, are you stupid? That's clearly from the bridge. And that's expert knowledge. And you have to put your expert knowledge to digitalize. You have to do it on your own. I can strongly recommend this, because at the end, it's always very difficult if it becomes very technical. And so you can do it on your own and use it. So at the end, I just want to show to you some applications which we are working on. So the partnership is very young. Nevertheless, we had several cases now where we go into it. That's very typical. You have to find these birds' nests here, or analyze this isolators, or finding signs, something like this. That's a case where you have to find on the surface of a production the missing screws or whatever it is, and you have to do this also regularly, because it can happen that they fall out. And that's also very nice. Here was the task to find the flash holder stuff, because they have to be always on the right position and complete. And to finalize, some examples is which I really like. It's in the north on Helgoland, because the birds are taking quite a lot of plastics and nets out of the oceans, and that's a big issue because they do die because they cannot bite this if they got, let's say, connected. I don't know the English word. And this is they do a statistics and want to push that they only can use nets which are on a biological base in this region, which will be probably very difficult to get this, but that's really a problem. Okay, and at the end, to finalize, you get a result. There you can have an individual result which also gets shot into your management system. And to summarize, I have to show you very quickly that with this combined solution, it is now possible to have all this to-dos on one platform at the end, and to be able to digitalize your at the end, it's also quality management for your objects or for your parts. All right, thank you very much. And if you have questions, also the CEO of Flynex is here, so he can also give you good answers for drone regarding questions.
Thank you very much, Dominic. Very impressive. So now's the time for your questions again. Please use the chat. First question from my side: what are the smallest objects that you can control?
That's also a question which I often got in the industry. There's no limit. It starts from 1 pixel and ends up to the whole image. The limit is actually the camera technology and the, let's say, the surrounding conditions like light. If you can imaging the object in a let's say way that you can analyze or see it. That's the right answer actually.
Okay, thank you. So, are there any questions for Dominic? You are all eating, right? Here's a question for Flynex. What is really unique in your product in one word? Again, Andreas, if you would like to turn on your microphone.
Yes, hello. It's scalability. That would be the one word. And the reason for that is and this is exactly how Dominic described it. The whole platform is built for applications to be highly scalable. So it is not about flying a drone once or bringing a cool project to life, but doing that thousands of times. And I had a presentation here last week at VDMA, and we right now manage across 36,000 objects that are monitored with drones on a daily basis in the industry. And therefore, this is very crucial, especially what Dominic is telling you, because you don't want to evaluate thousands of images, and you need to have that in an automated and scalable process. And this is the reason why the technology and the platform by design serves scalability.
Thank you. So Dominic, is the EI board? I don't think so.
Oh.
And what is your business model?
Yeah, thank you very much for this nice question. So everything is written on the scratch from our side, word by word, or And our business model is that we do see us as technology enabler. So that's the Flynex example is a very good example because there was missing the puzzle piece of a high quality vision AI. And that's what our strength is, and where all customers are also profit, because on a weekly base, we put new technologies we find in literature and also develop own on specific cases in the back end of the platform. So it's getting better and better and better. That's the strength of platform technologies in general. And we work together with integrators who have to solve this issue for the complete solution. We work together with also other platform or also with companies who drive through streets and everywhere where you need a vision AI technology. That's where we can come into place. And what our strength is beside the technology is that you can use your platform on your own. So it's not that we have several cases where we have already trained networks. However, the idea is that you or your customer, or especially the operator, is doing the let's say teaching, if it's a teaching case, and that's also with very less amount of images. So our strength is really giving this super easy access to this technology and also solve it on a very high level. We don't do end applications. We have no hardware and so on. So we really see us as technology enabler.
Thank you very much. Again,
just one more thing.
Short sentence.
Okay, just one. The thing with the business model is, yeah, you can say that you have an inspection as a service, depending on the object for an end-to-end process.
Yeah. So in case of this Flynex solution, of course, it's the whole package. It's yes. Otherwise it makes no sense. I mean, we have also other customers in the drone business, but to be honest, I really enjoy this because it's digitalized. You know where your data is. It's sorted. It's geo-referenced. So I think it's a very good solution at the end for this drone business.
Thank you very much.
Mm-hmm.
Also for you, big applause. Thank you both, Dominik and Andreas.
Yeah, thank you very much.
So, yeah, and now last but not least, our last speaker, Maximilian Hausmann. He's a robotics engineer at Spleen Lab. And yeah, Maximilian, we are ready for your insights.
Thank you very much for that introduction. I hope you can see my presentation. I'm Maximilian Hausmann of Spleen Lab. I'm in the hardware department, and today I want to tell you something about our newest use case. It's a cell tower inspection. Spleen Lab was founded in 2008, and Spleen Lab does not only want to create powerful AI, also safe AI. And I tell you today what's the difficulties about it and how we solve it. So a typical use case for cell tower inspection is that the operator flies that drone in an orbital trajectory about or around the cell tower, and he has certain difficulties, like keep focus on operating the drone and taking pictures at the same time. And often cell towers are not that like open on the field. They are mostly covered, or there are trees as a collision target, for example, and he has to make sure that this not happen. And usually he wants to take high resolution pictures of the cell tower, the antennas and the structure to like observe some maintenance problems and so on. And what Spleen Lab does, we create AI on the hardware, which means the drone itself takes over, as I show you later, which means that the operator just brings the drone into the air, and then the AI takes over and steers the drone around the cell tower. It takes, while the drone is flying, also high resolution pictures, and uses AI to calculate the flight path, and also to like detect objects and processes the general view and the perception. Yeah, for safety, you need not only one sensor, but multiple different sensors. They all have advantages and disadvantages. In this example, we have a camera and a LiDAR, but we could also use a radar. And as you can see in this graphs, each sensor has different advantages and disadvantages. For example, the low light performance of a camera is not always that good, but a LiDAR or a LiDAR don't care about day and night dependence. And we fuse all our sensors together and create a redundancy, and therefore also a safe general source of truth for our AI. And our AI can then reliable work with that data. To create such an AI, we need 4 key assets. We need a knowledge about the physics of the sensors and the sensor fusion, which is mostly my part. We have to know exactly how the sensor performs. Also, it is important to have data, experience, and strategy. And last but not least, safety for machine learning and deep machine learning. We have experts at Spleen Lab who are doing that right now. And we have also like payload integrators and operators. I'm also a drone pilot, for example, who connect these parts together to a reliable system. Yeah, thanks to our partners, we have also a reliable hardware. For example, from Auterion, we use the Skynode and the Skynode AI. The Skynode AI is a very powerful companion PC, which processes the inputs from the sensors in real time. So our nets are running on the drone itself, not on some cloud solutions or something. It's directly on the drone. And together with Allied Vision, with the Alvium 1800 and the Blickwell Q1, we are able to create the best experience and the best sensor data. Sometimes you have also smaller cameras, but in this special use case here, we use only that hardware. So how does that work? We have the ready for takeoff, like pre-flight checks. The drone is then ready for takeoff. Currently, the operator brings it to the air. So in the future, it will be a one-click solution. But in this case, we have to bring it in the air by hand. Then the AI takes over, which means that the AI is now on the full control of the drone and steers the drone to the right trajectory. During that, there is a position calculation happening, which processes all the GPS data and also the image data for perception and collision avoidance, and also calculates the flight trajectory. Then, as soon as the drone arrives at the cell tower, it does an orbital flight, takes high-resolution images, and also creates this 3D point cloud, as you can see in a few seconds. And then, after the mission, it returns back to home, lands safe and sound, and the operator can move to the next cell tower. That is our system. It's an early-stage prototype. We are not hardware developers or drone system providers. We use that systems only for testing out our software packages, which then can the customer buy or license. And so the drones are more looking like a prototype state, but that's that is not by accident. That is our system. So now I show you real results, which mean that I will share you a video of it. So that's typical flight. The drone lifts off. So the operator is now guiding the drone, as I said, in the right direction. On the left side, you can see the LiDAR raw data. On the right side, you can see the image data. And in the middle, you can soon see the detected cell tower. We have here one difficulty. There are 2 cell towers nearby. So the ground station has to decide which one we want to observe. And now the drone has detected the cell tower and is now steering the drone around the cell tower. The operator is just for safety reasons. He does not steer the drone. And the drone is now orbiting around the cell tower. As you can see here, the red dot in the LiDAR image is the center of the detected image. And now you can see the drone is steering around it with fast forward 2 times because of the small time amount in this presentation. You can see that the drone is orbiting with a time, in this case, about 5 minutes. And shortly after that, the drone comes back. So we are now right round and the drone comes back safe and sound, and the operator is then doing the landing procedure. The drone can this also by itself, but in this case it is a very early presentation or demonstration. So now the drone is able to do much more. Yeah, that's it.
Thank you, Maximilian. I think 1 minute left.
Yeah.
Thank you.
I tend to talk more than I want, so I try to be fast.
More time for questions. And here's the first one. How safe is your application regarding collision in case that an error occurs to the software system?
I read it by my own. How safe is your? So because of the sensor redundancy, it's not that possible that I think Stefan means that we are collide with the cell tower itself, right? So the first thing is that we keep a certain distance. That is also why we use a high resolution camera. And in this case, on this demonstration, the AI is taking over, but in case of something goes wrong during development process, the operator is capable of getting back the controls. So it's not like that the drone is flying away and saying goodbye, so that the drone operator has fully control if something goes wrong. Or do you mean, so yeah, I think, yeah.
Do you have further questions for Maximilian?
I think Patrick Schwarzkopf asked something. So your approach is mostly about automating the flight and image acquisition, correct? Yeah, that's one sentence that describes the use case perfectly.
Maybe you can give some other examples of applications. So
yeah, as the other Dominic talked also about it for one sentence, we have also a project which I am involved the most in the last time. It's about weeds, so different kind of weeds on a field which our drone detects and can then the AI can detect which kind of weed there is and does also a completely autonomous flight on it. That's also a collaboration with 2 universities, and that's also some interesting use case. We have also some use case with our partner Airbus, which is also perception and collision avoidance for helicopters. So we are not only providing AI for drones, but also for cars and aircrafts and helicopters. Yeah.
Okay, thank you very much. Big applause for you too. And thank you again to the two Dominics. Yeah, we are ready, we finished. So that was our third edition of the VDMA Robo Lunch. I hope you enjoyed it. Yeah, please let us know how you liked it. You can take a picture of the QR code in the picture, or you can use the link in the chat. So yeah, next Robo Lunch is coming soon. We will inform you about that. Thanks again for sharing your lunch break with us, and yeah, see you soon. Thank you.